going up to represent it's a big size. Oh dear Lord, this is permanent marker. Hello, welcome to Science Shop. Today we're going to be looking at the conservation of energy and in particular how it relates to gravitational potential energy and kinetic energy. Now consider this finely drawn human being over here. He's holding a ball above the ground, and because it has height, you say that it has gravitational potential energy. Now, as he lets go, what's going to happen is the height reduces, and so the GPE reduces. And just as it hits the ground, we can say that the GPE is 0 because the height is 0. Now what we want is a unit there, so it's 0 joules, okay? Because I called that 0, I'm going to call this 100 joules. Now, what happens to this GPE? According to the conservation of energy, it doesn't, you can't create it, you can't destroy it. It just gets converted from one form into another. So what's going on is that as it speeds up, it's being converted into kinetic energy. Now, kinetic energy at the top, because it's completely still, you would say is 0 joules. And then over here, what's happening is all of this 100 joules is converted into kinetic energy. Okay? And in the middle, we've got some kind of halfway house where GPE is 50 joules and the kinetic energy is also 50 joules. Now, if we have a look at the total energy in this system, we would call that mechanical energy. And I'm just going to write it here. Mechanical energy. And that is the GPE plus the KE. And at all points, if we have a look, 100 plus 0, the mechanical energy is 100. 50 plus 50, the mechanical energy is 100. Remember, this is joules. And 0 plus 100, the mechanical energy is 100 joules. So just bear that in mind. The total energy in the system is being conserved. You're not gaining any energy, you're not losing any energy. All of the GPE at the top is being converted into kinetic energy at the bottom, which leads to our second equation. Remember, our first one was this one here, okay? And the second one, we can just very simply say that the GPE, let's change pens here, at the top is equal to the KE at the bottom. Okay? Now, remember, the way we work out GPE is mass times gravity times height, and the way we work out kinetic energy is half the mass times the V squared. Okay, now, these questions are generally slightly complicated. So let's have a look at a few examples, and hopefully it makes sense. If you haven't already watched the previous videos on GPE and KE, make sure you do so because they'll help you understand these ones. And we're just going to have a look at these questions over here. Let's have a look at the first one. It says, a 20 kilogram rock falls from the top of a cliff. If the rock speed just before it hits the ground is 10 meters per second, calculate the GPE of the rock at the top of the cliff. Ignore air resistance. All right, okay. Bit of a challenge, that one. But let's just see. I've already written my equation up here. GPE at the top is equal to the kinetic energy at the bottom. So let's just punch in the numbers and let's just see what we've got. So we've got 20 kilograms over here, okay, times G, which is 10, times the height. We don't know what the height is, okay, just says from the top of a cliff. We've got half of the mass, so it's half times 20, and we got the velocity. Fantastic. This is going to be easy, right? Is going to be 10 squared over here. Now, what they're saying is calculate the GPE of the rock at the top of the cliff. Okay, so the GPE at the top is equal to the KE at the bottom. We've got all of these numbers. All we've got to do is work out these, right? So half times 20 is 10, and 10 squared is 100. Okay, 10 times 100 is 1,000 joules. That was reasonably simple, actually. Let's see if it gets any harder. Let's look at question D. It says a boy drops a 2-kilogram bag from a window 15 meters above the ground. If G equals 10 meters per second squared and ignoring air resistance, find the kinetic energy of the bag just before it hits the ground. Okay, so again, we're going to use this setup. This is our equation. Let's write it out again. We don't like to take shortcuts. Remember, the more shortcuts you take, the more likely you are to miss out steps. I don't like people to miss out steps, because if you miss out steps, you miss out marks. So let's have a look. So let's start with our equation, which is GPE at top equals KE at bottom. This is M times G times H. This is half M times V squared. Okay, so this is our base equation. 1 mark just for writing that. Dead easy. Right, a boy drops a 2-kilogram bag from a window 15 meters above the ground. Find the kinetic energy. Right, we've got basically everything here. All we've got to do is work out the kinetic energy over here. Okay, so you just work out this bit. So they tell you the mass is 2 kilograms times by 10 times by the height, and the height is 15. Okay, and it's going to equal the KE at bottom. We don't need to work out any of this stuff. We just don't need to. We've got all of the numbers on one side. Okay, so let's work this out. 2 times 10 is 20 times 15. This is going to be something like 300. Let's just make sure. Okay, 20 times 15 is equal to 300 joules. Okay, so this is the KE. Just make sure you have that written like that. So 1 mark for the equation, 1 mark for the substitution of the numbers, 1 mark for working it out, 1 mark for the unit. Very simple, okay? Let's have a look at E. Now these do get subsequently a little bit harder, but we've got to do our best. An object is dropped in free falling above the ground. If the object reaches the ground with a speed of 8 meters per second, find the height from which the object was dropped. Consider G equals 10 meters per second squared. Slightly more tricky question, but fear not. It's not actually that hard. I didn't know how to do these until my cat taught me how to do it. And if my cat can do it, you can do it. I'm sure of that. Let's have a look. Let's first of all start off with our equation. GPE at the top equals KE at the bottom. Okay? Half, oh my God, I'm making mistakes. M times G times H is equal to half M times V squared, okay? It's no big deal to make mistakes. Everyone makes mistakes. You just have to make sure you know how to correct it and learn from them. It reaches the ground with a speed of 8 meters per second squared. So half that times 8 meters per second squared. Okay, don't have the mass so far. And find the height from which the object was dropped. Well, they haven't given us the mass. So m times g is 10, and the height we've got to work out. Oh my God, this looks like a really tricky question, doesn't it? Well, it doesn't need to be. You've got mass on both sides, okay? Let's just put a times there so you can see we can actually isolate it. All we do is get rid of the mass. Boom. What you're doing is you're dividing both sides by the mass, getting rid of it. So that leaves us with 10 times h is equal to half times 8 squared. That looks a lot simpler. We've got to work out h now. So let's work out this part first. Half, now 8 squared should be 64, right? Yes, see, I'm clever. And half times 64 is, let's write it down here. I'm going to run out of space, but 32. Okay? So that's 10 times h. 10 times h, you see? So h is 32 divided by 10. H is 3.2 meters. You see how I did that? Slightly more complicated, but it's not impossible. Let's cover that up. There we are. That was my mistake. You can cover that up. Dead easy. You got the equation, 1 mark. 1 mark for the substitution. Now, what I had to do was I had to play around with the equation a little bit. Get rid of the m. Once you got rid of the m, it's straightforward. Nice and easy. Okay? Let's have a look at one more question, and it's going to be a same kind of like difficulty level. Okay? And if you could do this, you're a certifiable genius. Give yourself a pat on the back and make sure you buy a cake. It says a ball is dropped from, from two top a 30-meter high building. Doesn't seem to make sense, right? But anyway, it's 30 meters high. Find the speed of the ball just before it hits the ground. Okay, right, well, let's get this. Right, start off with the same equation. GPE at top equals KE at bottom. Okay, this is m times g times h, and this is half m times v squared. Okay, it's like that. Now, let's substitute in the numbers. Again, we don't have the mass here. We got a 30-meter high building, so m times 10 times 30, okay, is equal to half times m times, and we've got to work out the speed, so we've got to work out this v squared. Just get rid of this. All right, so again, what we're going to do is we're going to get rid of the m's on both sides. Divided by m on this side, divided by m on this side, and what we're left with is 10 times 30 is equal to half times v squared. Okay? Let's see what this gives us. So if you work out that, you're going to have 300 equals half times v squared. Okay? What you do is this half times, you take it over there, it becomes divided by half. 300 divided by 0.5, which equals 600. That gives us 600 is equal to v squared. Now, I don't want v squared, I want v. So to reverse it, what we've got to do is we've got to square root this one. So we do it like this. 600 square rooted is equal to v. So that's square root 600. And it gives us 24.49. Let's just call it 24.5. So v equals 24.5. And because v it's meters per second. All right? Have a look at all that. If you could do this on your own without help, without using a calculator, you're a genius. But it's not so hard. Okay, thank you very much for watching. Goodbye.